Okay, so a little bit about me, not too long, just very quickly. I've actually been involved with continuous delivery, and even before it had this name for a long time, and I've been speaking about it for the last 3 years now. So everything you'll hear today is actually something that I've done on projects. It's working. It's several clients have the things I describe here in production. So it's tried and true. So I hope you'll find it useful for you as well. I speak regularly at conferences as well, so I enjoy doing this. It's good fun for me, and I speak usually either about continuous delivery or about Flyway, my open source project for database migrations. We'll speak a little bit about it this morning and a little bit more this afternoon. And right now, a lot of my time is being spent on another project, which we won't go into detail about today, which is called Fontaine, which is still in private beta right now, and it's something which allows you basically to take a deliverable, let's say a WAR file or some application package, and it turns it into a virtual machine within a few seconds, and you can then deploy it on any cloud within a couple of seconds or minutes. So that's basically what I'm working on now, but we won't go into detail about that today. So we have a lot of ground to cover in the next 50 or so minutes. So I would ask you, if you have any questions, to please hold on to them till the end, so we can get through all the material, and then we'll have plenty of time to answer them. And if it's and if some people want to leave the room, or if we run out of time, we can. I'll be around in the hallway, and we'll be able to answer some more there. So that shouldn't be a problem. I'll be around the whole day anyway. So yes. So please hold the questions till the end. And now let's get started. So the goal of the presentation today is really we're going to go over the next hour to try to get a fully automated deployment of a complete application. So we're going to see what this means as well, what a complete application really is, into production multiple times a day with zero downtime. So we're going to have a look at what the steps are we need to take to achieve this, what we need to do, or what we have to put in place in our software architecture to make sure something like that is possible. Okay, but before we start, we actually have to take a step back and put things into perspective. Ask ourselves, this software development thing we're doing, what is it really about? Or what is the essence of what is actually the problem we're trying to solve? And it turns out, actually, our problem is a business problem. So I've invited my assistant here, which we shall call Montgomery, and Montgomery has an idea. It all starts, he thinks, oh, this would be really great, and he doesn't just have an idea, he actually wants to make lots of money with it. So Montgomery goes to his favorite customer, which we shall call Ned, and asks, hey Ned, I have this idea for this new feature, this new service. Would this be something of interest for you? And Ned says, well, sure, that sounds great. I'd love to have that. So Montgomery goes back to his company, goes back to his office, and goes and talks to Jimbo, his Java developer, and says, hey Jimbo, I've got this idea for a feature. Could you develop it? Sure, could do. And Jimbo develops the feature, and once he's ready, he goes to his colleague from operations, and not too many people from operations in the room, I hope. No. And ask him to get it deployed, and once it's deployed, Ned can use it, and once Ned uses it, he can give feedback to Montgomery whether it met his expectations or not, whether everything worked as he was hoping, and so on. So when we look at this full circle here, this life cycle, we can actually put a number of things on there. So on the left-hand side, we've got here our development process, which has improved massively over the last 10, 15 years. We've come from horrible waterfall into much more modern, iterative processes like Scrum, Kanban, where we have a much better and much healthier cooperation between the business and development. And that's actually been followed by, certainly in the last 5 or 10 years, by continuous integration really entering the mainstream, where today there are hardly any projects where this isn't the case either, where for every check-in we make sure everything's working and at least compilable and testable centrally. And then after that comes the focus of today, which is continuous delivery. And when we complete the circle, we get into lean startup territory, the stuff where Eric Ries, Steve Blank, and Bob Dorf are writing a lot about. But as I said, the focus of today is continuous delivery. So let's get started. But before we start, I would like to know, let's make a quick survey. How many of you work on a project where you go live at least once per year? Everyone? No, a few hands not? Okay. At least every 3 months? We're at about 3/4 still. Every month? Okay, some hands stayed down. Every 2 weeks? It's getting thinner. We have maybe 30% left. Every week? Okay, good. We still have a few in the running. Multiple times a week? Yes, very good. Every day? Oh, look at that. It's getting thin, but we still have about 10. Multiple times a day? Oh, yes. Congratulations for the winners. And it turns out they're not alone. So actually, there's quite a few companies, you know, that do this already. The first one is the world's biggest waste of time, at least for 1 billion people. That is, and they're actually very vocal about it. So they've been talking about this for a long time on their developer blog, and even though with their billion users and tens of thousands of servers, they have no problem to go live every single day. So they build a whole new binary. The whole of Facebook.com is actually one big executable, and they push it out with BitTorrent and all that. It's a bit of a complicated thing, but they managed to push that out every single day. So it's not a problem for them. The next one here, another big example, not quite as big as Facebook, but still very, very far towards the top of the largest websites worldwide, Flickr. Flickr is also, it's a shame, a few months ago, they used to publish this very interesting statistic on their developer website, which unfortunately is gone now, but they used to publish this statistic at the very bottom, so the website where they had their APIs and all that. They published this statistic about how many times they'd gone live over the past week into production. And you could tell on this statistic that on average they were going live maybe 80 times per week into production, and they have a couple of 100 million users as well. So so even at that scale for them, not a problem either. The next ones here, Etsy is a little bit smaller. I think they're ranked, I think 120 or so of the largest websites, but still, these guys also have described a lot on their blog about how to do it, and for them it's no big deal either. But I think the most well-known example to all of you is Stack Overflow. Who knows Stack Overflow? Everyone? Anyone doesn't know it? And these guys, they have it right on their website. So when you scroll down all the way to the bottom, this is a screenshot I made this morning, but it's probably going to be updated over the next couple of hours anyway, because they're in America. So when you scroll all the way to the bottom, in the bottom left corner of their page, you have this little version number there. And if we look at it, we see the version number starts with 2013, this year, 10, October, this month, and then 10, so that was yesterday in America, so I expect that they'll probably bump it up to 11 in a couple of hours once they wake up. So they're also going live all the time, and they're really, really big now as well. I think on the whole Stack Exchange network, they're about 100 million users as well, so not a big deal for them. So how can we achieve that in our applications? Well, first, we don't start from zero. There needs to be a solid base we can build on. And so what do we need in this solid base? First, we need a good development process. We need something where we have tight cooperation between business and development, where things are working well. So this is not an option. We need to really move towards more modern alternatives to make sure we can react quickly, get feedback quickly, and get it going. The next one is a solid build process. Now, this unfortunately is not a joke. It's something I had at at a client where they had 70 modules like that, and every time they had to produce a release, they would go to Eclipse and file, export, jar for every single module. So it's actually pretty scary, but unfortunately, it's still the reality in some places. So you need a solid automated build process that can run in one go after every commit to make sure that works. And you need good version control as well. I think that's definitely some basis as well. So again, this is an example that looks ridiculous in a lot of development shops these days. But I was talking to some people at some other conference there, and some major clothing brand from Spain, which shall not be named, is actually using zip files of some directory. Every time they make a change, that's their version control. They just make a new zip file and archive it, and that's still 2013, and they're quite successful. But if we look closer to us, we can actually see this happening in operations very often, where lots of configuration files and other documents are being edited without revision control, without having the possibility to look at who made what changes and reverting there. So even though it's not that present in development anymore, it's still very much out there, and that definitely should be solved much better. The next one here is something I still see all too often now, where you have an army of business people or an army of testers being pushed down, doing monkey work over and over again to test the same features and making sure every time it works. That, of course, has to be automated away so that the machine takes over, and the tester still has a role. He has the perverted brain where he can think about really good scenarios that would stress the software in a certain way that it could break. And then once we have these scenarios, they have to be automated so that they never have to do them again. So how does it look like? If we put all these prerequisites in a diagram, what does it look like? So we have Jimbo, and he's developing on his machine. So we've got his development environment here. And once he's ready with his code and he thinks it's working, he can run an automated build. And whether it's with Maven, Gradle, Ant, or whatever tool you fancy, doesn't really make a difference. He runs an automated build, and once that's working, he's ready to do some automated testing. And I'm actually quite a fan of the Google terminology here, which is the one I'm using, where they have basically 3 categories of tests. Small, medium, and large. Small is what you would typically see as a unit test, and a medium is something like component test does a little bit more, and large is like a black box system test. I won't go into too much detail about the exact distinctions, but it's on their testing blog. It's described very well, and they have hard criteria of how to split up the tests, and it's actually very good, because if you split them out like that, you can have the small tests giving you very quick feedback, whether everything worked there or not, and if they were successful, you can then move on to the medium tests, and if they were successful, once again, with that feedback, you can then start the large tests, and if they were successful, so this is something like Selenium or whatever you would use there, if they were successful, we know at least that as far as we're concerned, things should be okay. So we're ready to check in. We take the next step, we go to version control. We check in to Git, Subversion, Mercure, what we would like to use there. And then we have a neutral system which will check if everything's fine. And in our case, that's a continuous integration system that will say, okay, you checked in something new, but I'm going to double check to make sure you haven't forgotten to check in any files, or there's no dependencies on your local machine or whatever. So I'm going to make sure everything works well centrally as well. So once again, on that system, it could be a Jenkins, a TeamCity, what you want to use. We're going to run the automated build, the small, the medium, and the large tests, and we get feedback whether what we've checked in is also working centrally or not. So once we've achieved that, we're ready to move to the main part of today, which is deployment automation. Now, the first rule of automated deployment is something to use a little bit of Maven terminology here is to not deploy snapshots. Now, snapshots in Maven terms is really just some intermediate state of your software. It's not really a defined version, it's just what you happen to have right now. Now, what is the problem with that? Well, of course, you can deploy this piece of software and you can run it on your server and you can test against it and you'll get some results and that's all good and well. But at some point, you want to go to production and you want to make sure that once something is in production and a problem occurs there, you are then able to reproduce this problem on a different machine, maybe your local machine or somewhere else, to be able to investigate it and maybe fix something later. So you can't just deploy something. You actually need some defined state, which is a version of your software. So we've deployed just something. We've tested it. It works fine. Now we want to go to production, but we need a version. We need a fixed state. So what do? Do we create a new artifact and deploy it straight? But I would like to test it as well. I don't really want to create something new and not having tested it and turn it into production. So actually, I have to test it again. So I haven't really won anything, but I have to ask myself the question, well, why do we do this then? What's the reason why people do that? And the reason is very simple, is that traditionally, creating a release has been associated with a lot of effort. It's been associated with lots of manual actions. It's been time-consuming. And so today we're going to have a look at how we can reduce the effort of creating a release down to zero. So we have our diagram here. And all our tests pass successfully on the continuous integration server. We are ready for the next step, the release process. So we're going to trigger a release from the continuous integration server. A release really is two things. The first thing is saying, okay, to use subversion terms, for example, revision 217,305 is now called version 4.7 of my software, so we tag the version control. On the other hand, we now have a new player that comes into field, which is the artifact repository. And the artifact repository is really the binary equivalent of the version control system. So what we're going to do here is, instead of storing the sources, we're going to store the artifacts that were created with the release so that we can retrieve them later. So that's our compiled code and everything that goes with it that's going to land in there. So once we have that, we are ready to ask ourselves, well, what do we deploy? What is this complete application we were talking about at the very beginning? What actually matters? What do we have to get into production? Well, the first thing is our code itself, of course. We want to make sure our application is actually running. So we need the code, but the code is actually rarely able to run by itself. Very often, we need some configuration so that it knows in a certain environment how to behave, which other systems to connect, how to make sure it's basically acting properly there. And then the next one is, in this case, for who's using relational databases on their projects? So we have the vast majority. Yeah? So most of the applications actually want to persist something. They want to store some state somewhere, and so most of us here use relational databases, and relational databases are conceived in such a way that they have a fixed structure in which they would like to persist information. And so if the business requirements change, and if the code requires new fields, or if things go away, this structure needs to evolve with our code. So we need to ship a Delta script as well to make sure that it gets adapted to what we require. Now, code. We hardly ship just classes by themselves. And we don't just copy a single class file here, another class file there. Very often we have a deployment package. Now, deployment package is a big word for something that could be a jar file, a WAR file, and EAR file, a zip file, whatever you want, just something that kind of bundles everything that fits together as one unit so that you can then deploy it. Now, how this gets deployed, that's another question. And very often, unfortunately, the answer looks like this. Well, the person that normally does it isn't there today, but I do believe that we have to copy this over there, rename this, change a couple of permissions, create a directory, execute this script, and then maybe it will work, but I'm not sure. So the first step really here is to say, we're going to formalize this knowledge in the form of a deployment script so that everything here gets automated and is usable by everyone and isn't stuck in some dirty wiki page or in somebody's mind. Once we have a deployment script, we already have the first potential synergy appearing, because if within an organization you have several deployment packages that fit the same structure, you can then reuse the same deployment script to deploy all of them. And so what does a deployment script do? Well, it can be as trivial as you want. So it can be just backupping your existing system if that's necessary, stopping it, retrieving a new version, installing it, starting it, and off you go. So it can be as simple or as complicated as you want, but I think as simple as possible is always a good rule to follow. So, what does it look like? We've got our artifact repository, and again, we have a new player now, which is our target system. I'm just calling it target here, because from a technical perspective, it doesn't actually make a difference whether that's a development, a test, a QA, or a production system. From a technical perspective, it's all the same. It's just all business risk and political stuff. If you need an additional manual step before that or whatever. But from a technical perspective, all the same. So we have our target system where we have our deployment script. And so the release process triggers the deployment script. The deployment script makes a backup, pulls the new version from the artifact repository onto the server, stops the old one, installs the new one, and starts the code again. So our new application is up and running. Good. On to the next part, configuration. Configuration is actually something we can divide into broad categories. The first category is, well, maybe it could change someday, so I made it configurable. And the second category is actual differences between environments, so that you just cannot connect to the same database from everywhere, or you need a different mail server or whatever. It's just your different environments are structured that way, and so you express this last bit of difference in configuration. It's of course a very good practice to have your environments as similar as possible and nearly identical, with this being the last little bit of difference you have between them is the configuration. But so, how do we deal with these two kinds of configuration? Well, the first one, I say, if it may change someday, it may also never change. So let's not pay the price for it. Let's put it back into the code, and if it changes in 6 months, we might change it then. We'll produce a new release, we'll see. It's no effort, it's just one commit. And if it doesn't change, we never had to carry the cost. We never had to have all these configuration values and all these indirections. It's just straight there. The other category, the configuration that portrays the differences between environments, well, I'm saying that goes back into the deployment package. Why? Because both the application and the configuration are actually very tightly coupled. They share the same lifecycle. In a certain release, you will then be dependent on a certain set of services or certain things being there, so you will expect these configuration values to be there. And in the next release, some of these things might go away or some new things might come. And so they're actually very tightly coupled, and there is no need to separate them. If you package them together, you are sure they will always fit. And if something needs to be updated, no problem. A new commit, a new release, we're done. So what does it look like? We've got our development package with our code, and we now add the configuration. But we very often don't just have one environment, we have multiple environments, which means we need multiple sets of configuration. But then comes the first question. Which one do I choose? Or better said, how do I know where I am so that I know which configuration element to choose? Well, there is a very simple technique called environment detection. It's a big word, really, for the simplest possible algorithm to find out where you are. So this could be looking at your IP address, host name, ranges, or simply the contents of a file /etc/my environment. And if the contents is development, then you're in development. And if the contents is production, it's production. Or it could just be a system property you pass to the JVM that says your environment is test. Done. So once you found out, so in this case test, we know which piece of configuration to pull, and then the code can automatically configure itself for the correct environment from that. So we've got a deployment package that is able to run identically in every environment, and it will just configure itself automatically for where it is now. So how does it look like? We've successfully deployed our application, and the new version is running. We perform environment detection, we find out we're in the QA environment, for example, and then we pull the right set of configuration files so that we can then connect to the QA database, the QA mail server, whatever we need in that environment. Now, the database delta. The database delta is a bit of an odd thing, really, because you can deploy 10,000 new lines of code and nobody will care. You just push them out into production, you've run your tests, whatever, it's fine. If you push out 3 lines of SQL, it's a different story. This guy's back. He's checking what is changing here. I need to have another look over it. And that's absolute rubbish. The reason that is rubbish is this. There is this misconception in the industry for some reason that DML, so just select, read, update, delete is somehow a lot more innocent than DDL, where you can create and drop tables and do whatever. And this is very widespread, actually. You see this in a lot of organizations. But if you take a step back and think about it from a risk perspective, so let's say I have a table with account data. So if I make a mistake in an update statement, and instead of just updating the one record, I zero out all my account balances, or I drop the balance column, at the end, the risk and the result is the same. Either I have a very good backup of my table, or I can close my business. So so this is really something, as soon as you have the possibility to make destructive changes, so that could be update or delete, you have the same risk as a drop or as an alter table you would have with DDL. So they're really on the same level, even though historically we've thought differently about it. So how do we deal with it then? Well, I'm saying, again, back into the deployment package. Why? Again, the central word here is lifecycle. The lifecycle of the DB Delta is very tightly coupled to the application. The application will expect to have certain tables, certain columns available, so it can read and write values there and make sure everything's there. And so the DB Delta provides that, but why would I decouple it? Why would I risk that certain things would not be there when I would need them? They are tightly coupled, so they belong together in the deployment package. But not all my problems are solved with that. If I have my database here, the next question that arises when I have my deployment package with my DB Delta and everything there is, in what state is my database? What has run against this database? Which objects are present and which ones are not? Which views and which columns and which tables are there and which ones still need to be run? And even when I found that out, I have the next problem. I may have multiple update scripts, and they have implicit dependencies as well. I cannot rename a column before having created a table. So there as well, I need to make sure a certain order is being kept. So how do we solve that? Well, the first ones to really provide a good answer here were the Rails guys. About 10 years ago now already, they came up with the Rails migrations, and really the first structured way at solving this problem. And I myself have also got a framework here which does that, which is called Flyway. This is for the JVM, and basically how it works is it will insert an extra table in your database, and this table will be a bookkeeping table. So it will keep track of which Delta scripts have been run at which time for which version, and it will then be able to query this table later so that it can then see, okay, my database is at version 5, let's say, and locally I have a whole bunch of Delta scripts here all the way to version 8. So once I start a tool like Flyway, it can then migrate, it can find out we're at version 5 and migrate to version 6, 7, and 8 before the rest of your application starts. Now I think that the most important message, certainly with this slide, is actually not Flyway itself. I think it's just to use any tool to solve this problem, because it's actually a very widespread problem, and it gets even worse when you think about the number of instances you have, because even on a 5 developer, on the development team with just 5 developers, if each developer has 2 database instances, one for unit tests and one just for running the application, and then you add the CI system onto that, and then a development, a test, and a production system, you have 14 instances that you need to keep in sync, and it's really a tough job. So you need to use a tool to do this, and on the Flyway homepage, I've put a comparison matrix for all the major tools, at least on the JVM in that space. So I think that the most important thing there is to find the simplest tool that would work for your project. Maybe it's Flyway, maybe it's a different one, depending on your requirements. But I think the message is at least use a good tool to solve this. So how does it look like? We've started our application, environment detection, auto configuration, and then we connect to the correct database for our environment, and then a tool like Flyway will find out that the database is at version 7, and we have Delta scripts up to version 10, so we will migrate to version 8, 9, and 10, and then we will start something like the Hibernate Session Factory or the rest of our application, so that from a technical perspective, there is nothing left in the way for Ned to use it. So, now we're going to discuss a couple of specific problems to make something like that possible, to be able to do this at any time. So a very common scenario here, so I'm just drawing out a bit of an example. So we've got a registration component, and Ned uses our registration component, and that kind of triggers the sending of some mail through some mail service. All good and well, just a standard example. And then one day, somebody from business heard that well, if you that happiness goes through the stomach, and if you would ship just a little bit of candy with this welcome letter that said, "Hey, welcome, we're happy to register you as a new user," we would actually get a lot more happy customers. So they decide that, and unfortunately, it doesn't fit in an envelope anymore, so we need a package. So what do? Well, the classic thing is we start refactoring, and we refactor, and eventually the software will evolve so that we're able to send packages. All good and well, except for one thing. This doesn't happen like that. It takes some time, and what do you do when during this time an urgent fix needs to be shipped to production, or there is some other smaller feature that is urgent, that is ready, that needs to go out? What do you do during this time to make sure you can still release and still move your software project forward? So the classic answer to this question is branching. We must branch because then we can just do it like this and it's fine. But that brings a number of problems with it. The first problem is that as soon as you branch, you don't want to sacrifice your quality control. So you want to make sure it's actually still on the same level, which means you need to duplicate your CI infrastructure to make sure that the branch is equally well tested. But the bigger problem is refactoring. Once you have different branches and you start refactoring, the longer these branches live, the more complicated a merge gets afterwards. And if you've been through a big, painful merge, you know what it is. And it's and the worst consequence of that is that you then say, okay, we're not going to refactor anymore once we have the branches, and then you start to build up technical depth and you get into real trouble. But there's actually a very good alternative to this that doesn't have these problems. And it's so simple, you actually won't believe it. It's really, just the whole concept is really that easy. It's instead of, how does it typically look like when we perform a release? We have stable software, then we refactor, break, fix, stable. Yes, we must release, quick. And then we go again and refactor, fix. And then we release, and off, we can produce a new release again. And now, the revolutionary concept, let's get ready, we don't break the software anymore. It's so simple, and yet, all we need here is to keep the existing branch running and add the new one next to it. This could be as simple as adding an if statement that will choose whether we're going to the old or the new path. It could be hiding new functionality in the UI so that a certain menu item doesn't appear. It's basically just a strategy pattern of choosing, and this opens up many new avenues. So it's you can then decide, of course, in which environment you would like something to be active. So you can say, okay, I want the parcel service in this case to be active in development, but not yet in test or in production. And then once that's okay, you then activate it in test, and once it's proven to be okay in test, you activate it in production. But you don't have to make it binary. You can start, for example, activating just for part of your users, so that you can activate a certain feature in production for your internal users or for some trusted customers, or so that you can start playing around that axis. And if it works for them there, then you can bring more and more users on board, and then gradually refactor it so that when everybody's on board, you can get rid of the old service, and you then remove the feature toggle. The feature toggle is the logical thing that allows you to choose which way you go. And then you remove it so that you don't have to deal with the complexity anymore afterwards. It's not necessary anymore, it's gone. So, the next scenario is another common image you recognize. So we have our client, and it sends a request to some load balancer, and the load balancer sends the request to the app server, and the app server asks the database to run everything, so to retrieve the data. So classic scenario. Now we've seen how we can release at any time with a previous technique with feature toggles. Now we're gonna have a look at how we can do it without interruption and without impact on the user. So we have our existing software, and next to the existing software, we install the new software. So the old software keeps on running. We've seen how it works. The software starts, environment detection, auto configuration, and then we connect to the database. And maybe our database migration tool will find out that we're at version 9, and we actually ship version 10 here. So we upgrade the database. And this has to be done in a backwards compatible way. It has to be done so it's at least compatible with all the versions that are currently in production. Hopefully just 2, but it could be more. This is very important because you will have this scenario in a lot of cases. As soon as you have more machines and you don't want an interruption of service, you will always have a mix between versions when you do a rolling update. You, let's say you have 10 machines and you take the first one offline, you update it. Once it's up, you take the next one offline, and so you roll so that you, like in a stadium, like in a football stadium, always doing one machine at a time, so you evolve. And once that's working, so you have always a period where a different version. So we're going to talk a bit more about this technique this afternoon in my Flyway talk. So, but it means that certain things you used to do, like just renaming a column and all that, are not possible anymore. You need to put in intermediate steps to make sure it's compatible with both versions. Once you've achieved that, we are ready to let traffic onto the new instance. Now that should be okay, except for one problem. When we have an existing user, he comes in, he used to have his session over here, if we have any sessions, and now he comes here, and this server here doesn't actually know anything about this session. So we have to be very careful when we keep state on the middle tier about the consequences. And so there are a number of solutions for that. You can start sharing the state in a cluster and doing all kinds of things, but there's actually a much more elegant one, and that's to move the state away from the middle tier, so that you either push the session to the front, which is what a lot of new frameworks are doing now, like the Play framework and all that. It's been common in Rails and in other ones for a longer time. Or if you don't want some sensitive information, even in encrypted form, to go to the client, you can push the session to the database or memory cache and keep it there and just have a small reference to the front. The main point is it has to leave the middle tier and go either to the front or to the back, so that you don't have the problem of a user coming in and not having there. Because there is actually an alternative where you don't need this, and that's called sticky sessions. That's been done for a long time. And how does that work? Is basically you come in here, and all the existing users go there, all the new ones go here, and then at some point you stop taking new sessions over here, so only the existing ones will be there. And once they've all logged out after a while, you will be able to shut down that server. But that takes a long time. Even just on the regular business application, you don't even need a 24/7 system. Just on the regular business application, this already can take 8 or 10 hours. If somebody logs in the morning and works the whole day, it can take a long time before you can decommission the old version. So I think the new way there, which is called blue-green deployments, where you alternate between a blue version and a green version without actually replacing the actual version, is much superior to that. So let's summarize. What does it look like if we put everything together and we look at it with the tools we have available today? Jimbo is running his development in IntelliJ or Eclipse, and then starts a local build with Maven, Gradle, or Ant. He then triggers small tests with JUnit, and medium tests with DBUnit, and large tests with Selenium, and he's ready to check in Subversion, Mercurial, or Git. Then there is Jenkins, Hudson, or Team City that will run the Ant, Maven, or Gradle build, and the JUnit, DBUnit, and Selenium tests, and we will then perform a release so that we can tag Subversion, Mercurial, or Git and push the artifacts in Nexus or Artifactory. Once we've done that, we execute the deployment script on the target system that will pull the artifacts from Nexus or Artifactory. We'll then run the code, perform environment detection, auto-configuration, and the database migration so that Ned can use the software as it is today. So all the pieces of the puzzle have actually been available for a long time. It's just a matter of combining them. So once again, one deployment package with auto-configuration and environment detection, auto-configuration, and database migrations with feature toggles and careful state management, because as soon as you have state, it can be beaten. most of what I've talked about today is actually available in this book. We don't share the exact same line, but there's a lot of very good ideas in here. So I really recommend you have a look at them. It also goes much deeper in a number of areas than we were able to cover today in 15 minutes. But there's one last thing I would like to talk to you about, and that's once you've put this whole process into place. Once everything's working, once the releases are really rolling out after every commit, it will change the way you think. After you've pushed it out to production, you have a much higher responsibility for every commit. But if the process is going smooth, you also have peace of mind that it'll work. So you need more discipline, but once you've experienced it, there is no way back. I think it's like the first time someone tries continuous integration, and then you try to live without. It's the same thing here. Once you have the smooth process going through, it's such a comfortable thing. Never have to put effort into it again. So that's a couple of links, but you'll get them in the PDF form. And that's actually all I had for today. So